When creating custom table view cells for use with dynamic data, there's a step or two more we need to take to allow us to use the cell efficiently as a prototype. We're going to start like we did with the static cell by designing it in Interface Builder in a storyboard scene. Now, earlier, we went through the predefined styles provided by Interface Builder for use with prototype cells. And you might have noticed that the dropdown allowed us to specify a custom style. So let's do that. If you click on your prototype cell, we have a style of basic right now. We can go ahead and click custom. When we do that, the title label disappears, and that's expected because we haven't defined one for our custom layout. Now, like the static cell, we're going to start here by modifying the height of the cell. Select the cell, and in the size inspector, you're going to set the row height to a custom height of 80 points. Now, if you run the app now, the cell is still the same default height of 44 points. And this is because resizing the cell in Interface Builder for dynamic content is just for our benefit when designing. To tell the table view to redraw all the cells at a height of 80 points, we need to implement a method from the UI Table View Delegate protocol. So in the Contact List controller, let's add some code. Now, right after this data source section over here, we'll say mark delegate. So table view delegate. Now the code we're going to add here, the method is called table view height for row at index path. And we'll need to add the override keyword. This method allows the table view to ask the delegate, which is the table view controller by default, to specify a height to use for a row in a specific location denoted by the index path. We want to adjust the height for all rows, so I'm just going to return 80 here. So basically, the height for rows at every index path should be 80. Okay, now let's go back to the storyboard scene, to our prototype, and add a few subviews. So we're going to drag out an image view, drop it in there. Now we'll place it at the left edge, and we'll give it a few constraints. So 0 points at the leading edge, 0 points for the top constraint, 0 for the bottom, and a width constraint of 80 points. That way, basically, the height will be maxed out to the height of the cell, which is 80. So if we give a width of 80, it's a perfect square. All right, let's add those constraints and update the frames. Next, we want a label to display the contact's name. So let's drag one out. We'll give it some random text just to specify a name for now. And we're going to give it a top space to superview constraint right here, so 8 points for that. And then a leading space to the image view, another 8 points. And add the constraints and update the frames. Just for the heck of it, let's show which city the contact is from right in the main view. So we'll add another label. We'll say this is city. We'll give this a color of light gray. We'll give this an alignment of basically, to the left margin so that the text flows to the left, from the left to the right, rather. And then we're going to give it a couple constraints. So we'll align this label to the name label. So we'll align the leading constraints. And then we'll give it a top space to the name label of 8 points. Add constraint, update frames. For the last bit of our custom cell, we're going to add another image view and place it on the right. In the Teacher's Notes section, there is a link to download an image, a star. Add that to your assets folder. Okay, so let's drag another image view out. We'll place it on the right edge. And then a couple constraints. So first, before we do that, actually, set the mode on the image view to aspect fit. We'll set the image then to that star we just added, which I already have in my list, so right there. And then we're going to align the center Y to superview, so basically center it vertically in the container. We're going to give it a trailing space to superview constraint of 8 points, and then a width of 22 and a height of 22 points as well. Okay. Now that we have our prototype design, well, where do we go from here? Do we add outlets? Not yet. let's add a new file to the project. So right-click, New File. And we're going to select a Cocoa Touch class and make sure it is a subclass of UI Table View Cell. And we're going to call it Contact Cell. Now that we have this class, let's go back to the storyboard scene and set the underlying class of this contact cell prototype that we're designing to the subclass that we just created. And we do that in the Identity Inspector. So drop down and select Contact Cell. Now that this prototype is associated with a subclass, in the Assistant Editor, make room as always. So in here, it's going to make sure the cell is selected. And then this obviously doesn't go to the right place. So I'm going to go Manual, Contacts, Contact Cell. And here in this subclass, we're going to create outlets from the prototype in Storyboard. So first, this image view right here. So we'll call this Profile Image View. Next is the name label. So a name label. Then we have city label. And finally, this button that we added, which is an image view. So we'll just say favorite view or favorite icon. All right. Now, unlike the static cell, where we created outlets directly to the table view controller, we can't do that here. If we did, which row would that pertain to? We will have several cell instances at any given point. So which of those are connected to the actual outlets? By creating the outlets in a custom subclass, every time we create a cell, we're going to use the subclass's type's exposed outlets to assign information. Now, before we actually get to implementing that, we need to make a change or two. So let's go back to the standard editor and go to the contact list controller right here. The important part to get this all worked out is the cell for row at index path method. So here we're using an identifier to determine which prototype the table view needs to use for cell creation. We didn't change the identifier when creating our new cell, so this line of code right here is still correct code. The difference now, though, is that the cell created from this method won't be a UI table view cell instance, but our more specific subclass that we just created. So we need to cast it to the right type. So all we're going to say is guard let cell equal, or we'll call this contact cell to be more specific, equal table view DQ reusable cell, blah, 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 as contact cell, which is our custom subclass. And if this doesn't work, I'm going to fatal error, because we do need that cell every time. Now, the cell doesn't have any of these properties, text label, image view, and detail text label, because we just created that subclass and we know that these don't exist. Instead, we need to use the outlets we added as stored properties to assign the correct data. So first, we'll say contact cell dot profile image view dot image equal contact dot image. Next, we'll say cell or contact cell dot name label dot text, and to this we'll assign the contact's name, or first name rather. Then is the city label, so contact cell dot city label dot text equal contact dot city, and finally we'll say if contact dot is favorite. Let's go to the contact, so sections, and go to the type. So this should be called isFavorite. My mistake here. I'm still working with Swift 2 rules in my head. So we know that in Swift 3, Booleans are written as assertions. So this should be isFavorite. So now back in contact list controller, scroll down to cell for row at index path. So now we can say if contact is favorite, then cell.favorite icon, or contact cell again. Shouldn't have renamed that. It keeps typing cell out. So contact cell.favorite icon.image equal, And we'll use that image literal. So we'll say star, and Xcode will worry about loading that for us. And now we have, oops, I have an error here. So let's add image. Now we have all the setup code we need. We can return the new cell. And if we run the app now, we have an error. Okay, so what's going on? I just need to make that fix here. Okay, so let's go back, run the app, and now we should have custom table view cells to use in our master list. Unlike static cells, with custom cells, we had to do a tiny bit more work. Now, this included providing an implementation for a UI table view delegate method to define custom row heights across the entire table view. Then we had to design the custom cell in Interface Builder, create a custom subclass for the cell, assign the subclass as an underlying class for our prototype in Interface Builder. After we do that, we had to create outlets for all the subviews that we added to this custom class. And finally, using a reuse identifier, we can create a reusable cell and cast it to the right type before we used it. We're almost done with our app. Over the next few videos, let's wrap up by implementing an additional feature and refactoring some of our code. Neither of these are table view topics per se, but I think you'll find good use for these concepts down the road.